So this video will honestly be super quick. It's just talking about what synthetic division is. So synthetic division, it's kind of the same as long division. It's a different method, but we're kind of trying to get to the same place. So we're starting with a higher degree polynomial. In this case, it's a degree 3 polynomial. Okay, and we're dividing it by some linear term like x plus 1. So with long division, remember we had this x to the third minus 2x squared plus x minus 1 on the inside. And we had x plus 1 on the outside. And we did all that stuff to try and whittle it down to smaller and smaller numbers. In this case, what we're doing, it's kind of a different method. So for synthetic division, how you set it up is you draw kind of a half a rectangle like this. Okay, and when we're thinking of x plus 1, so we're taking this kind of expression here, dividing it by x plus 1. Remember, if we're dividing it by x plus 1, our x value is really just negative 1. Okay, so if we had a graph, remember, of like say one of the factors of our graphs was x plus 1 and say like x minus 2 or something, the zeros of this graph would be at negative 1 and positive 2, right? So negative 1, positive 2. So if we're dividing our function by x plus 1, then that means that the x value that we're really looking at is x is negative 1. Okay, so on the side of our kind of vertical bar here, we're going to put negative 1. And if we take the negative of what's kind of on, like beside the x, this is going to be a plus here, okay? You can do it the same way if that confuses you. You can do positive 1 on the side, and if you do positive 1, you just have to make sure that this is a subtracting sign. So let's actually do it both ways. Okay, let's do it both ways. But let's start with the negative sign because I prefer that. I prefer adding numbers rather than subtracting them. And what we do for the stuff inside the box here is we look at the coefficients on all these numbers. So the x cubed, negative 2x squared, positive x, and negative 1. So, oh man, there's an imaginary 1 in front of the x cubed here. There's already a negative 2 there. There's an imaginary 1 in front of the x, and there's already a negative 1 there. So with synthetic division, in this top row here, we're going to write the coefficients of this polynomial. So the coefficients are on the x cubed 1, on the negative 2x squared, right, negative 2. On the positive x, it's going to be positive 1, and then minus 1, we just have minus 1 there. So for synthetic division, your coefficients are always on the top row. And what we're going to do now is, when we synthetically divide, we always bring down this leftmost number, and that's going to start us off. So we're bringing down this 1, our first number here is 1. Okay, the next thing we do is we take this number 1 and we multiply it by this negative 1 on the side here. So 1 times negative 1 is negative 1. And this is where the plus sign comes in. So what we have right here is we have negative 2 plus 1. So the numbers that are always vertically, like kind of one below the other, we're going to add those together. So negative 2 plus negative 1, that's like negative 2 minus 1. So that's going to be negative 3, right? Now what we're going to have is negative 3, this new number, times negative 1. Well, negative 3 times negative 1, that's going to be positive 3. And now we have these two adding together. 1 plus 3 is 4. Now our new number 4 is going to multiply into negative 1. 4 times negative 1 is negative 4. Okay, and negative 1 plus negative 4, that's going to be negative 1 minus 4, which is negative 5. Okay, so the last number you get here, that's your remainder. And all the numbers to the left of it, that's called your quotient. So just like how this top row was the coefficients on our original expression, these three numbers here are the coefficients on our quotient. So there's going to be a 1x squared minus 3x plus 4. So positive 1 minus 3 plus 4. Those are our coefficients. And then remember our remainder was negative 5. So we have to add this minus 5 over what we were dividing by, minus 5 over x plus 1. Okay, so this is your answer. This left side here is your quotient, and this is your remainder. And if we were to use long division, we'd get the exact same answer. I honestly think once you have synthetic division down, it's much, much faster because we're not dealing with all the x's and stuff. We're just dealing with numbers and coefficients. So now that we know how to do it when this is negative and this is positive, let's do it the other way. So let's do the same exact question. Okay, the same exact question, except instead of taking, like if this is x plus 1, instead of doing minus 1 and then adding, let's take positive 1, right? So positive 1 and subtracting. So we're still going to bring down this 1. Now we're taking this 1 and we're multiplying it by positive 1, not negative 1 anymore. So positive 1 times positive 1 is going to be 1. And then we're going to go negative 2, and now we have a minus here. So negative 2 minus 1, that's going to be negative 3. Now we have this negative 3, right, times positive 1. That's going to be negative 3. Now we're going to have 1 minus negative 3. So remember, those become pluses if we're subtracting negatives. So we're going to have 1 plus 3. That's going to be 4. Okay, now we have our 4. We multiply it by our positive 1 there. So it's going to be 4 times positive 1, which is 4. And now we have negative 1 minus 4. So a negative minus a positive number, it's going to be negative 5. So notice how we get the exact same answer, right? We get our remainder of negative 5, and our coefficients 1, negative 3, positive 4. So we get the exact same answer, whether this is like positive, this is negative, or switch it around, the first one's negative, second's positive. But the main idea is if you take the opposite sign of what you're dividing by, right, you can make this here plus. And if you take the same sign, so if it's x plus 1, and you do plus 1 on the side, then this has to be a minus here. Just keep that in mind. So our answer for this one would be 1x squared, right, minus 3x plus 4 minus 5 over x plus 1. And that's our remainder here, 5. Okay, let's do one more example here. Divide 2x to the fourth minus x cubed plus 3x squared plus 8 by x minus 2 using synthetic division. Okay, so remember synthetic division, we always kind of set up our bars here. And the top row of kind of this set of bars is going to be our coefficients on our expression. So the coefficient in front of the x to the fourth is 2. And then we have minus x cubed, so minus 1x cubed. Then we got plus 3x squared, so we got a positive 3 here. And notice how we don't have any x terms. There aren't any like 3x's or negative 10x's. It jumps right from x squared to a constant 8. So we have 0 x's. We're going to put a 0 there. Okay, and then we have positive 8 finally. All right, so right now let's take, if x minus 2 is the thing we're dividing by, I'm going to say this is positive 2. Right? I'm going to take the opposite sign of what's inside, and I'm going to go adding, because I like to deal with positive numbers and adding. And notice how we could have done negative 2 here and minus, but I just like to use positive numbers, like I said. So remember, always bring down this 2. This is our 2 here. 2 times 2 is going to be 4. Negative 1 plus 4 is 3. 3 times 2, right, that's going to be 6. 3 plus 6 is 9. 9 times 2 is 18. 0 plus 18 is 18. 18 times 2 is 36. 8 plus 36 is 44. So our remainder is 44, right? The number to the right side of our final, like if we were to draw a bar kind of separating them, our last numbers are remainder, and then the 4 to the left of it in this case are our coefficients. Okay, so 18 is our constant, right? 9 is our linear term, so our x. 3 is our quadratic term, so our x squared, and in this case, there's a 2 there, going to be 2x cubed, because we're taking x to the fourth, and we're dividing it by a first degree polynomial. So if we have something to the fourth dividing by something to the first power, it's going to be to the third power now. So it's going to be 2x cubed plus 3x squared plus 9x plus 18 and then our remainder is 44, so plus 44 over x minus 2. Okay, so that's our answer there. Synthetic division honestly doesn't get a ton harder than that. Um, and we're not really talking yet about factoring, but in my next couple videos, synthetic division will be huge in factoring high degree polynomials. So not just dividing them, but we're going to be able to factor them as well. Okay, so just stay tuned for that, and I'll see you soon.